This is one of my Fortec 2.0 cars. I actually really like this platform, the Traxxas Fortec 2.0. Now here I'm not running it, taking GPS time. The GPS, to be honest, wasn't working. Plus, I figured I'd just run it. I would just run it and see what the motor temperatures would be. And to be honest, the motor runs really, really cool. And this is with a 48 spur gear and a 42 pinion gear. Keep in mind, this is a higher end system. It is a Tekin system made for short course, and it fits. It just fits. It fits like a glove, but it fits with the RX8 ESC. As you can see, it's very fast, and this is 2S only. So here's another run. And later on in the videos, I'm going to talk about the calculations. So before you spend money on systems, what should you consider first? So in other words, math. So I'm going to show you how to do some math, calculate, see if a system is worth getting or not. The other thing too is keep in mind that these are linear calculations, so they really only work with similar motors. So I'm going from comparing a Hobbywig 60mm to a Tekin 62.5. Now here are some temperature readings. Now outside it was probably about 14 degrees Celsius, so 57 degrees Fahrenheit, but this is the temperature of the motor, so 99 degrees Fahrenheit, 37 centigrade, so very good. How fast can a Fortec go on a high-end 2S system? Well, I'm going to talk about it in the video. Now, I do have speed runs later in the video. It's the last few minutes, 5-6 minutes. But I wanted to go over the math just so that you can run your calculations before you spend money on systems, because you could potentially waste your money and not meet your goals. So my goal was to go as fast as I could on just 2S, and the reason why is I'm tired of 3S. I like 2S, I like 4S, but on something like this, I'm going to be carrying, say, 3-4 packs. Well, I already have a bunch of 2S, so why not 2S? Save the money on the batteries instead of having them. Plus, 3S is not really something I use often. 2S I use a lot, and I have many of these packs. So, based on my test, what I ended up doing is the Hobbywig 3660. This is a 60mm long can versus this one is a 62.5. So close enough for the purpose of this. This one is a little longer, has more torque. This is a really nice system. Now, this system, like I mentioned, is about $160. This system is about $200 more. So just the motor is going to be about the same as the motor in ESC over here. But again, if you buy the ESC and the motor, you buy them separately, you can get discount codes. So it'll be about $200. And considering I won't have to buy those 3S packs, it's going to, say, break out even. Why? Because I already have a bunch of 2S packs. So my goal was really, how close can I get to 70? Can I get close to 70? As long as I can break 60, I'm going to be happy. So this is the spur and pinion with which I achieved this 113 kilometers per hour, which is approximately 70 miles per hour. So I decided to just estimate my speed if I were just running 2S. Same gears, so these do not matter really. And it's very straightforward. So I take 113 kilometers per hour divided by 3S, multiplied by 2S. Now, if you're wondering, why not 11.1? Well, because it's linear. So this would be 11.1, this would be 7.4. 3.7 times 2 is 2S, 7.4. 3.7 times 3 is 3S, 11.1. So this way I avoid using larger numbers in decimals, especially the decimals. So 113 divided by 3, and then I multiply, so order of operations, left to right, then you multiply by 2, and I get an estimated speed of 75.3 kilometers per hour. So that's 75, which is approximately 46.8 miles per hour, which sounds about right. But the important thing is, what if I got this Tekin Pro4 system that has high torque, 2S system, and it can do 4,300 kV. Well, what gears can I use? Now, if it weren't for the gears, it probably wouldn't really be worth it because the speed difference is not going to be that much. This motor has way too much torque. Just to let you know, just in case you're wondering, why not the VXL? VXL is 3,500 and it can do 70. I never actually got 70 out of my VXL. If you did, I don't know, it was probably weather or something. I have no idea. Tailwind. But you cannot run it all day. With this Hobbywig system, I can run the entire pack and not worry about the motor overheating. And this is without a heatsink, additional heatsink on the motor, without a fan on the motor. This is the reason why I would recommend this system. Plus, it's a little less expensive than the VXL. Now, this Pro4, same thing. This is why. Now, for this one, I found a hot racing spur gear. This one from Florida because that's where they had them. 48 tooth. Now there are some modifications that you have to do, but the pinion, I used a 42. Now in order to use a 42 tooth pinion, you are going to have to modify the cover for the motor and the gears. So you're going to have to modify that cover, just cut a hole through it so that the gear doesn't hit the cover, or else it's not going to run. But I ran through the calculations. So what I did was I took the estimated speed that I got on 2S, which is 75.3 kilometers per hour, and then I'm going to divide that by this ratio. And the reason why I'm dividing by this ratio is because I'm going from the speed, ground speed, to the tires. So I divide by the tires and multiply it by the pinion so that I can get to the motor. That's the reason why. And the original, I actually do the opposite, because now I'm doing the opposite. I'm taking the speed of the motor and, I'm going to the spur from the speed of the motor. So here I'm going to be multiplying. Now, I could say divide by this number, but it's just the reciprocal, as I did over here. So I'm going to be multiplying by the reciprocal of this, and the reciprocal of this. So again, I'm going from the tires to the pinion, and then pinion to tires. That's if I were dividing, but I decided to multiply it. So I already took the reciprocal. So this is really the equation that you want. You want to flip the actual one that you're going to use and keep the other one the same. So I went ahead, 75.3 multiplied by 42, divided by 48, and then multiplied by 55, divided by 37. And this is equal to 93.9 kilometers per hour, which is about 60.8 miles per hour. But here's the thing, the KVs are not the same. So now we have to compensate for the KVs. Now remember, I said it's linear. We're using the same voltage, 7.4, so we don't have to multiply these out because it's linear. To be honest, you can drop the last two zeros, so just 43 and 40. So now I took 97.9 kilometers per hour, so take that, multiplied by 43, which is your new KV, and divided by the old KV. This is going to be equal to 105.3 kilometers per hour, or 65.4, which is golden. That's where I want to be. I want to be above 60, below 70 miles per hour, right? As close as possible to 70, which this is good enough. And the nice thing about this system is when I tried it out, well, that's the speed I got. 104 kilometers per hour. This is the actual speed that I got, which is about 64.6, 65, right? Close enough. And just based on my calculation, I'm negative 1.2% off. Now, it's a negative number because I'm lower than the actual. If this had been positive, it would have meant that I would be above. So I take the actual minus the theoretical, divided by the theoretical, and then multiply by 100%. That's how I got the percentage. So again, this is how you can use math before you spend money, before you waste money. Just find the gears that you can actually fit in the vehicle, find the motors that are available, and then run the math. So again, I know I sort of skipped a portion here, but you take whatever the theoretical speed that something had, or a measured speed. So you can use my numbers and then play around with the gear ratios. And you're going from the speed to the tires. That's why you multiply by the spur. And then into the pinion, as if you were going into the motor, for example. So you divide by the pinion. And then you would divide by the old pinion and multiply by the spur, as if you were going now from motor to tires. Now again, the reason why I have multiply here is because I already took the reciprocal, right? Because dividing by a fraction is the same as multiplying by the reciprocal. So this is really the correct one that you want to use. So just follow those through. If you look at these numbers, just plug in your numbers. But again, I got really, really close, and the motor stays very, very cool. You would never be able to run this much at this speed with a VXL system, for example. And now I can just use all of my 2S packs without having to buy any more 3S packs, which was really my goal. Because to be honest, 65 miles per hour and 70 miles per hour on a 10-scale touring car that I'm just going to be bashing with, it doesn't really matter if that is so really insignificant for bashing. If I were racing, that's something I would care about, but I'm not with this car. I'm just bashing with it. So this is more than enough speed for my intents and purposes. So, like I mentioned, I have some running videos, so let's go ahead and watch them. So these are some of the actual speed runs. It's not all of them, but I want to show two of the quickest and then some of the slowest, so you can see. So it's very consistent in general. This body probably looks familiar. I've had this body for a century and a half. It's been way over a year, but it works and it's still holding despite some crashes. It's also very aerodynamic, so I really do like it. Now the tires, again, I'm running sweeps. The very nice belted tires. That's the type of tire I would recommend. Now the camera is losing focus. It's actually very low light outside when I was recording this, so the very last part you'll see it's dark. But see how quick it is? I mean, you can just visualize how quick the vehicle is. And like I said, it hit top speed was 104. The lowest was, well, less than that, but not by much, and you will see. So this is 104. This is one of the high ones. And the motor stays very, very cool. So I was never worried about it getting anywhere close to max temperature. Then again, it is a cool day. It was actually an enjoyable day, about 14 degrees Celsius, 57 degrees Fahrenheit. So, yeah, nice day to go out and race. On a long sleeve. You might want to wear a jacket, maybe. Not always. Not if it's windy. Well, no, if it's windy, you want to wear one. But here goes. So I'm going to go ahead and take it out for another run. And the acceleration is great. Now, you cannot just punch it and go full throttle. It'll spin all the wheels, flip the car. You'll probably blow out a belt on the tires. But I don't hit top speed until probably there. That's when I go full throttle. There's also a marker on the road, so I have to be careful. That's the reason why I'm going slow. And then once I think I'm going to miss it, then I just go. Usually I would do this near the airport. I just didn't have a chance, so really wanted to get this out there to show you. But this is 101. This is actually the slowest run by far. And the only reason why is because I started accelerating full throttle later on. That's probably why. If I gave it just a few more meters, I probably would have hit that 104. The next run is also going to be a little slow. And to be honest, I don't recall ever losing so many body clips. I still don't understand. Well, all right. On one of the images, one of these scenes, you're going to see why I lost body clips. But I'm still very surprised as how many I lost. So I'm actually going to go with a larger size. I'm not going to go with that small little size that comes with the Fortec. Or I may just use the rubber body clip holders. Arma makes some really good ones. Here goes the car again. Again, I apologize, you can barely see. But car goes. There's the marker. Found it. That body just holds so well. It's not the first, and it's probably not going to be the last time I do that. And that's one of the things I like about the Fortec 2. They're very durable cars. This thing has taken a beating, but there we go, 102. So that's the second slowest. Other than that, I'm usually hitting the 104s. And by usually, I mean I was hitting the 104s.
What? Oh, my hair! My arm! My room!